In 1991, a 47-year-old Italian man checked into a hospital for a routine surgery. He went under, he came back, and something was gone. Not his memory, not his ability to walk, or think, or laugh. Something smaller. He stopped dreaming. Completely, permanently, forever. His wife noticed it first. Not the dreams. She couldn't see those. He was quieter, slower. He'd forget things he never used to forget. He'd sit in a room and not say anything for long stretches. She described it to his doctors like this. He came back from that surgery a different man. The doctors didn't believe her. The surgery was a success. The scans looked fine. The man was alive and functional. But she was right. And what happened to him over the next 2 years would quietly terrify every neuroscientist who read his case file. Here's what you think you know about dreams. You think they're random noise your brain processing the day, firing signals, producing weird movies you forget by breakfast. That's what most people believe. That's what most textbooks said until very recently. They were wrong. Because if dreams were just noise, if they were byproduct, static, meaningless, then losing them should change nothing. But that's not what happened to the man from Italy. Within months of his surgery, his memory started slipping. Not dramatically, just edges. Names he should know, faces he'd seen 100 times. His doctors ran tests. His brain looked structurally fine. Then his emotional range started narrowing. Things that used to move him, music, his grandchildren, old photographs, started producing less. He described them as nice, pleasant, the way you describe a meal you don't remember eating. By 1993, the researchers studying his case published their findings in a journal almost nobody outside neuroscience reads. The title was quiet, clinical, bureaucratic, but what it said was this: remove the dreams, and something essential about being human starts to disappear. Now here's where it gets strange. In 2017, a team at UC Berkeley ran a study. They took healthy volunteers and monitored their brains during REM sleep, the stage where dreaming happens. What they found broke a 30-year assumption. Your brain during dreams is more active than when you're solving math problems, more active than when you're having an argument, more active than almost any waking state they could measure. This is not what noise looks like. This is not what a byproduct looks like. Your brain is running something at night, something expensive, something it clearly cannot afford not to run. Evolution does not keep expensive things around for no reason. Evolution is ruthless. It cut our body hair, shrunk our jaw, rewired our eyes, all to save energy. It does not waste resources. So whatever is happening in your brain right now, tonight, while you're unconscious and helpless, it matters. We just don't know what it is. There are currently 4 major competing theories about why we dream. Not 1, 4. And the scientists behind each of them think the others are wrong. Theory 1. Dreams are emotional regulation. Your brain replays painful memories at night, but with the stress chemicals removed. It's basically surgery. You relive the experience without the pain until it stops hurting. Matthew Walker at UC Berkeley calls this the overnight therapy hypothesis. Theory 2. Dreams are threat simulation. A Finnish philosopher named Antti Revonsuo spent 15 years arguing that dreams exist to rehearse danger. You dream about falling, being chased, failing an exam, because your brain is running simulations, preparing you for threats that might never come. Theory 3. Dreams are memory consolidation. While you sleep, your brain decides what to keep and what to delete from the day. Dreams are the visible surface of that sorting process. Theory 4, and this is the one that keeps researchers awake. Dreams are creativity. Your brain at night makes connections between things that your waking, logical mind would never allow. The structure of benzene was reportedly discovered in a dream. Paul McCartney heard Yesterday for the first time while asleep. Dmitry Mendeleev claimed the periodic table came to him in a dream. 4 theories, decades of research, billions of dollars in neuroscience funding. No consensus. Back to the man from Italy. Researchers eventually identified what had happened during his surgery. A tiny region of his brainstem, an area called the pontine tegmentum, had been damaged, almost invisibly, just enough. That region is the switch, the thing that turns dreams on. And when it broke, the dreams stopped. And when the dreams stopped, something upstream started failing too. Memory, emotion, creativity. The things we think of as most human about us. All of it connected to a process we cannot explain. Here's what that means. Every night, tonight, last night, every night of your life, your brain has been running a program. A complex, expensive, evolutionarily ancient program that touches your memory, your emotions, your ability to be creative, your ability to feel like yourself. You've never seen it run. You experience fragments of it, strange images, impossible situations, people you haven't thought about in years, and then you wake up and shake it off and pour your coffee. But it ran. It always runs. And somewhere in there, it's doing something to you. Something important enough that without it, people stop being who they were. We sent humans to the moon in 1969. We mapped the human genome in 2003. We built machines that can write poetry, diagnose cancer, and beat every human alive at chess. And every single night, inside every single human brain on this planet, something happens that none of those machines, none of those scientists, none of those billions of dollars can fully explain. Your brain is doing something to you right now while you sleep. It has been doing it your entire life. And the most honest answer science has, after 100 years of trying, is this: we think it matters. We're not sure how, we're working on it. Tonight when you close your eyes, that program will start running again. You won't feel it, you won't remember most of it, but something will happen. Something always does.